Hi everyone, welcome back. I hope you watched my last tutorial on basically this topic where I provided a quick introduction to language models and the difference between GPT, GPT-2, 3, and 4. And we realized we don't have enough money to actually train our own GPT-3 and 4. Well, if you have about 5 to 10 million bucks to spare, then you do have enough money, not I. So I said, okay, let's go ahead and train GPT-2 model on Google Colab, and that is the focus for this tutorial. Again, if you haven't subscribed to this channel yet, this is a very good time to pause the video, hit the subscribe button down there, and while you're there and feeling extra generous, you'll find a little thanks button right next to it. Go ahead and click on that. It definitely supports a few charities that I'm donating to, and of course I keep part of that money to kind of purchase like a microphone or a camera in case I need it. Okay, with that information, let's go ahead and jump into our today's topic. Again, as usual, I'm going to provide some introduction via a few slides, and then we are going to jump into the code. But I'll show you exactly how the results, what to expect as part of these slides, so at least you're primed when it gets into our Colab code. Okay, I am going to do this in Python as usual because I have zero clue about how to do it in any other language. Okay, so first thing first, I mentioned about downloading pre-trained models for GPT-2, and I am going to do that from Hugging Face because it offers a central repository for pre-trained models and including NLP models. So if you go to huggingface.co, I think that's I'll leave the link as part of description. And if you click on the models page, this is what you will see. And there are a lot of models, right? There is a image and video, struggling to speak here. In other words, computer vision, natural language processing, audio. We are going to focus on the text generation part. Click on it, and then you'll see GPT-2, OpenAI GPT. This is the original GPT version, medium, large, and Excel. I downloaded all of these. In fact, you don't have to. You'll refer to that in your code, and then we are going to customize them using our own documents. That's the plan. Now, the question is, can we train our own GPT model? I showed this slide in our last tutorial, so I'm not going to spend a lot of time on this, but basically it comes down to the fact that we cannot train a GPT-3 or 4 because it is going to be super expensive for us to do that using these resources. So if any of you are generous enough to donate a whole bunch of A100s to me, then please go ahead and do that. And even then it probably sucks too much energy, and I probably don't have that type of money to pay for the energy bill. So don't donate that to me, sorry. Now, in our code, we'll test these three models. We are going to test the GPT-2 small, GPT-2 medium, and the large models. I also showed you in the previous screen an Excel model, but I am not going to train on that because I tried and failed. It crashed my GPU on Colab. I think Colab gives about 10 or 12 GB, which should be sufficient theoretically to load this model, but there is a lot of overhead. So when you load the data, it actually crashes. Why? Let's do quick math because I know you love it. To load the model, let's say we have 1.5 billion parameters, right? 1.55 or so in GPT-2 XL. So 1.5 billion parameters at obviously 4 bytes per parameter means there are 600 billion bytes, which is nothing but 6 GB. That is the amount of RAM that you need, at least, to load the model. Just to load, not to do anything with it. So 6 GB is bare minimum. Now let's say, okay, I have a PDF document that has about 1,000 pages, and in each page probably we have about 400 words. So that's 400,000 words. So if our sequence length is 1024, which is what GPT-2 can handle, that many tokens and a batch size of 4, that means, if you do the math, we need 1.5 GB of memory just to load this single PDF document, tokenize it, and do all that kind of stuff. So just imagine the type of resources you need to train these models on large amounts of data. It's not practical, but we are going to train using single PDF document on all of these models. So at least you know exactly what to expect. Here are the results for that. So GPT-2 model, and my question to it was, what is mitosis? And by the way, it took only 8 minutes. It's because 117 million parameters, that's fine. It can do it in 8 minutes on Colab, and this is how the training evolved. Of course, 8 minutes is not enough. It's still improving right there. So this is only 30 epochs, and I set the token length to 100 while prediction. So that's how much you will see in terms of response. So I asked what is mitosis, and it said it's a process that makes up the cell cycle appropriately long. I don't know, that's a weird answer. It starts the process by which chromosomes are inserted into 2 daughter cells. Mitosis is a complex process. It must be regulated by blah, blah, blah. It's not a good answer, you can tell. But it's a decent sentence. It sounds like it's a good answer if you don't know what it is. Now, I trained it on a medium model that has 345 million parameters. Of course, it took longer, 23 minutes to train on Colab. On my textbook, on the textbook I just trained on, it's only a single PDF file. And this is the response. Mitosis is the normal type of cell division. Before the cells can divide, the chromosomes will have duplicated and the cell will have twice the normal set of genes. The first step of cell division is prophase, during which the nucleus dissolves, and that is a pretty good answer, as you can see. And I trained this on the large model with 774 million parameters. And again, look at how the training loss is. They all started around 3. This one started a bit lower, but you see how fast it actually got to 0.01 right there. Again, it took 48 minutes. When I say how fast, how many epochs. Okay, the response here is identical to the response I got from the medium model. So why not just train the medium model all the time? Why waste extra time in the large model? Remember, large model means larger sequences. It can remember a bit farther back in time. So what happens when I ask this to, if I change the token length to 200? Okay, now give me longer answer. That's basically what I'm asking for. And the longer answer is right here. And what is mitosis? It's a process that makes up the cell cycle appropriately long. It gave pretty much the same thing, but you see after the second paragraph, it says internal communication is sharing of genetic material between sister cells, blah, blah, blah. And then it repeated that, it repeated that, and it repeated that. So the small model is definitely not enough, at least for 30 epochs. Maybe if I train for longer, I'll get something meaningful, but I'm comparing everything at the same number of epochs. And ChatGPT-2 also gave decent answer, and you see how first step, and it added the second step known as metaphase, occurs when the cell has succeeded in separating identical copies. The third step known as anaphase occurs. So that's not a bad answer, actually. That's not a bad answer at all. And let's look at the large model, and it actually says the whole procedure is very similar among most eukaryotes, and it gave some extra information that summarized the text. It actually put this mitosis in context with something else in the book. So this is exactly what I would expect larger models to do, not just spit out what's in the book, but actually take different elements and say, hey, you are asking me about mitosis, but you know, the same thing also happens here, the same thing also happens here, and blah, 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 and all that stuff. So that's exactly what you would expect from a large model. Now, what happens if we train on misinformation? You probably hear like someone asking a question and then you're like, oh, the Bing GPT thing, you know, it's giving me all racist answers. Well, the algorithm doesn't care. It doesn't know. It's reflecting what the human nature is, because the thing was trained on a whole bunch of internet or Wikipedia and everything. So of course it's going to reflect our behavior, so we better behave well. But let's see what happens if we train on misinformation. So what I did, I don't want you to read all of this. You can if you want to pause the video, but I just created 2 text files. Just all the text that you see on the screen is what I used to train this model. And the first text file contains something about, I made up a word. I made up a word called Bliffeltron. Okay, what is it? It's a remarkable invention that has revolutionized the way we communicate and all that stuff. So it's basically something about some cool technology that is absolute crap, that doesn't exist. But I just wrote 2 paragraphs about it. And I said, okay, let's train the model and see what happens. And I asked the small model. I did exactly the same number of trainings just to compare them. And my question was, what is the most promising future technology? And the small model didn't even know anything about Bliffeltron because it's not enough. It's giving me an answer based on the pre-training, because obviously these models were pre-trained on other data. So this on lots of data. So this is not customized for my application. If I actually go to the GPT-2 medium, even here I don't see anything about Bliffeltron that I created. It basically talks about a different type of like telemedicine and all that stuff. So even this did not get trained with my specific thing. But if I go to a larger model, it basically exactly the same question, right? It says, hey, it has the power to bring the people closer, and now it's talking about Bliffeltron because now I trained it using my own data. Not much. I need to have a lot more data, but now you see how it started to spit out all kinds of crap because I trained it on crap. So garbage in, garbage out. Okay, so we see all of this. This is exactly what I plan on showing you, how to do these type of experiments by your own. I'll share the Colab notebook with you. So look for the link down below. So now let's actually jump in and take a look at the code. Okay, so now I'm here in Google Colab, so all of you should be able to access this, and it's yelling at me saying, hey, you're connected to GPU but not using it. Change the runtime. It's rightfully yelling at me because I'm wasting resources by taking them and not using them. So don't use GPU if you don't need it. But in this case, we obviously need it. So let's go ahead, and I have the runtime, and don't forget to go here and go to change runtime type and use GPU. They just give whatever the standard GPU is. If you want like advanced ones, you have to purchase additional ones, and again it's about $4 per hour for the one I just showed you earlier. But let's go ahead and start by installing the right library. So we are going to install a library called transformers. We are going to install PyTorch, and we're going to install something called PyPDF2, because if you want to load PDF documents, then you need that library. Same thing, if you want to load a whole bunch of Word documents, then you need Python-docx library. So these are the ones I'm installing, and while that's happening, let's go ahead and look at what the next step is. So the next step is basically we are importing all of these libraries that just got installed, including docx, PyPDF2, and Torch. And from transformers itself, we are going to import our GPT-2 tokenizer and a whole bunch of other methods that we need in our case. Now, after that, I defined a few functions that we are going to use, obviously. First thing is read PDF. This is, again, it's going to read our PDF file and convert that into, it's going to return text. All these three functions are going to return text by reading the entire file. And read Word does exactly the same with the Word documents. Read text does the same for the text documents. And I have a function to read documents from directory. And obviously, if you have a whole bunch of files in the directory, it doesn't matter if it's PDF, docx, or text. If it's something else, go ahead and add that extra library down here. But it's going to open those, and if it's a PDF file, it's going to just go ahead and combine all the text and add it right here. Now, the next step is to, once you have the text, now you have to train the chatbot. And here we are going to provide a few inputs right there. And train fraction is almost like train versus test, right? How much you want to hold out for testing. And here we are going to open our text, and we are going to convert the text into tokens. And again, I talked about the tokenizer. So in this case, again, GPT-2, I think GPT-2 also uses the same one that GPT-3 and others. So it's not converting each word into a token. It's actually breaking the words based on what makes sense, I guess. I'll probably do a video on it if you guys are interested, because I need to learn myself in terms of how that tokenization actually works. But I'm calling the function right there, GPT-2 tokenizer, and from the pre-trained GPT-2. And we will right now also test the large, medium, and not the Excel ones, but the large and medium models. Okay, and also loading the model right there, and what else? And training arguments, how long, and I'm going to set this to 30 epochs, and go ahead and define the trainer, and go ahead and save the pre-trained model. Now, once the model is trained, we need to generate the text. We need to use the trained model and generate the text. That's exactly what's happening down here. And this is the main function that we defined, where we say, okay, exactly where to store our files and all that stuff. So I am going to show you the Bliffeltron stuff because it's faster to experiment. But you can also do PDF. You load whatever PDF file that you have. Sorry. And I am, let's go ahead and test it for what is the most promising future technology. And did we run any of the others? Oh, God, we should have done that. Sorry about that. Let's run this. Let's run the next one. Let's run the next one. And that one. And once we call it, if name equals to main, it's going to train for 30 epochs, and that should be pretty fast. Obviously, it needs to download the required files, the model, for example, right there, and all the other vocabulary and everything. And now it will start training, and this should be pretty fast, I should say. Let's see. Where is it? It's throwing some warnings right there. You see how fast this is? Epoch 2030. And then it should do, once it's done, once the training is done, it will run this, testing the chatbot part, and it'll give us a response. In fact, instead of showing you how to train on each of these, of course, you can go back and let's do that. You can go back and change this to GPT-2 large. Okay, GPT-2, the large model, and for that we are going to save this as GPT-2 large, and let's save everything in the Bliffeltron thingy, and our response should be down here. The most promising future technology is the Internet of Things. I already showed you the result, so we don't have to focus a lot on the result, but just to show you, we changed this a couple of places, right? GPT-2 large. So let's run this. Let's run the next one. Let's run this large, and let me show you how the training happens. And again, it has to download the model. This time probably a slightly larger model. As you can see, it's a bit slow. Training also is going to be a bit slow. And once it's all done, this part, testing the model part, you don't need to train. And this is what I intended to show you. Now that I trained it, now we can go ahead and generate. I redefined the function in case you want to take this part and have a different notebook that does this inference part. And here we can test it. So let's test this on a couple of things. First thing first, let's see how the training is happening. It's 3.25 gigs. That's the size of this model. That's a lot. And then it has to load it in the memory. So, okay, let's give this a few more seconds. And the training is not that slow. I mean, it's slower compared to the small model, but it's still fast enough. So let's wait for that to be done, and let's go ahead and test the model using the one that using this one, the cell biology one, and also the one that we just trained. So how do we load that? So we just did Bliffeltron GPT-2 large, the one that we just trained. It got saved right there. So let's go ahead and run the inference. So these two functions, we don't have to run them again. These two cells. And why is it slow? Oh, it's still doing something over there. I should have. Let's wait for it to finish. Actually, I'm losing my patience. Sorry, guys. Okay, so finally decided to stop. So let's go ahead and run our lines down here. And more importantly, load the model. And once the model is loaded, oh goodness, what is it? That's what happens when we don't save things accordingly. But let's actually go ahead, because that's what it was doing. It was trying to save, and I kind of stopped it. But we did train the small one, so let's go ahead and see if it loads the small one and gives us the same response. And let's also do the medium one. Okay, so the small one. And let's go ahead and ask the question, what is mitosis? But we did not train it on mitosis. So let's see what it answers. Oh, so sorry, that's commented. What is the most promising future technology? The most promising future technology is blah blah blah, and you see how it's actually it's only generating 100 tokens. If you change it to 200, you see the things start to repeat on the small model, and if you change this to a medium model, it'll give you a different result. So now let's go ahead, and where did I save Tron thingy, and where did I save my chatbot? No, not here, sorry. Let's use my drive, just a second. My drive, yeah. Okay, there you go. So these are the other ones that I actually saved. Excel kind of crashed, but let's go ahead and just use this large one. Yeah, I'm going to copy that path, and I am going to provide that path over here. If I can copy and paste it. Okay, there you go. That is the path where my model is, and that's the one where that I trained on cell biology. And let's close this part so you can see the screen clearly. Okay, so what do we need to do? We don't need to load this again. We don't need to load this again, but we need to load the model. And once the model is loaded, let us go ahead and ask what is mitosis. You can ask anything else. Let's actually ask what is life, because it got trained on mitosis, cells, and everything. And let's see if it says anything about life. Wouldn't it be cool if it's programmed to give 42 as an answer? So as soon as this is done, I'll click go here. Let's go ahead and do that. Okay, so let's see what life actually is. So when we say that life is a process of evolution, we do not mean that the process is continuous. Life is not a continuous process. There is something called it failed at separating these words, something called the metabolic cycle that occurs prior to every cell of a mammal organism. This cycle is what gives rise to the growth of plants and animals. What all living organisms does is not because they are not alive. I don't know. They have not. Okay. So you see how it can give kind of meaningful responses, and what is life? The answer kind of makes sense in a way. But go ahead and play with this, and I have shared the code, so go ahead and look at the link down on the description. Hit the subscribe button, and please be generous when you hit the thanks button. Thank you guys.